In this video, we're going to be finishing up our unit on ionic compounds, and you're going to be learning how to write formulas. So we have already practiced taking the formula and writing out the name. This is going to be the reverse. So you're going to be given the name written out, and you'll need to do the chemical formula with the symbols off the periodic table. So when we're writing a compound, the positive charge must always balance out your negative charge. When we do our math, your plus charge or minus charge had to be equal to 0. That absolutely has to happen. So for example, if we have potassium chloride, we know that potassium is the letter K with a +1 charge, and we know Cl, chlorine, is a -1 charge, and those already balance each other out. The +1 and the -1 balance each other out. So KCl is fine for the formula. But if we look at calcium bromide, we have calcium, and that's in the +2 family, and we have bromine, which is a -1. So one calcium and one bromine are not going to balance and equal to 0. It takes 2 of the bromines in order to balance those, and so our chemical formula, we need to include that subscript of 2 behind bromine so that our reader or whoever knows that it takes 2 bromines to make that a neutral compound. Some rules for the crisscross method. This crisscross method is just a way to always ensure 100% of the time that your plus and your minus charges are going to add up and be equal to 0. So the first thing you want to do is write down the symbol and the charge of your cation. Your positive always goes first. And then you're going to write down the symbol and the charge for your anion, your negative. That'll be your nonmetal. Then we're going to crisscross those charges, and I'll show you what I mean by crisscross, but you're going to write the charge number as a subscript behind the opposite ion, but you don't include the plus or the minus, just the number. So you're only going to be writing that number, whatever that charge was, as a subscript behind your opposite ion. If it's a 1, we just understand that 1s we don't write. Okay, it's just an understood. And you want to make sure that your formula is in the lowest possible ratio. Okay, so let's practice. Let me show you what I mean by crisscrossing. We have the calcium bromide example that we just saw, so we know that it takes the 2 bromines, but this is what the crisscrossing method would look like. So first rule, write down your symbol and your charge for your cation, write down your symbol, your charge for your anion. So we have those first 2 rules done, and now we're going to crisscross. Crisscross says we're going to take the number from the charge and we're going to drop that number down behind the bromine. So that 2 is going to be behind the bromine, and the 1, the charge on the bromine, gets written behind the calcium. So in essence, you have crisscrossed your charges, and we have Ca with a 1, Br with a 2. So no writing the plus or the minus, just the number. But 1s are understood. We do not need to write 1s, so our final answer would just be the CaBr2. That's the crisscrossing method, and that will always 100% of the time make your charges balance to 0. Let's try magnesium sulfide. Magnesium is in family 2, so it has a +2 charge, and sulfide is the element sulfur. Sulfur, we change the ending to sulfide. So that is the capital letter S, and it is a -2. So at this point, you should have the first 2 rules written down. And then our crisscross method says that we're going to take the numbers, not the plus or the minus, but we're just going to drop those down behind the opposite element. So Mg2S2. Now, this formula is not in its lowest whole number ratio because we have 2 Mg's and 2 S's. We can reduce it down to the lowest whole number of 1 magnesium and 1 sulfur. Let's go to zinc iodide. Now zinc is a transition metal, but zinc is one of our exceptions. It's always Zn with a +2 charge. And then we have iodide. Iodide is the element iodine. It's in the halogens. It's a -1. So there's our two elements, our cation and our anion with the charges, and we need to, again, crisscross the numbers. And so we would have Zn with a 1, iodine with a 2 behind it, and we need to remember we don't write ones, they're just understood. So Zn, I2. Potassium sulfide. We have K with a +1, potassium's in the first family, and sulfide again is sulfur. It's in the oxygen family. It has the -2. And again, you still need to crisscross your charges. So the 1 is going to go behind the sulfur, the 2 is going to go behind the potassium. Ones are understood. We don't write them in our final answer, so K2S. Now again, at any point in time in this video, please make sure to pause it. You can always work ahead and then try, watch the video and check and see if your answers are correct. So maybe you want to try that now for beryllium nitride. Pause the video and give this one a try. And if you're repausing it or replaying it, here is the way you should have handled filling this one out. Beryllium is in the family 2, so it's a +2 charge. Nitride comes from nitrogen. Nitrogen, we take the ending, comes nitride. So we have Be with a +2, and nitrogen is has a -3 charge. And so when we crisscross those, we are going to have Be3N2. All right, one more, and then we're going to talk about our polyatomic ions. We have tin with a 2 in parentheses. If you take a look at tin, it's one of your exceptions. It's one of them that when we write the name, it has to have a Roman numeral. That Roman numeral tells us what the charge is because it's one that we don't automatically know the charge for it. So when we have that 2 here in the parentheses, that tells us the charge on our metal. Tin is going to have a +2 charge in this case. And then chloride comes from chlorine, which is a -1 charge. So this is what you're starting with. And then the rule still follows that we need to crisscross. Ones are understood. So we have SnCl2. Now, when we are writing formulas that have polyatomic ions in it, all of our previous rules apply. So we're still write the positive, we write the negative, we're going to crisscross our charges. What we need to remember is that a polyatomic ion is actually 2 or more elements acting as one unit. So if we need 2 of those units, or 3 of them, then we have to place our unit, our group of atoms, in parentheses, and we need to put the subscript, when we crisscross, that subscript goes behind the parentheses so that we can say that we have 2 of whatever's inside the parentheses. So when you write a parenthesis and you put something in it, okay, we have our 2 or our 3, whatever it is, you're saying it takes 2 of these. So let's say we have SO4 sulfate. You are saying that it takes 2 sulfates, 2 of those units to balance out the charge of the positive. Let's do a few examples where we would need to use parentheses and then sometimes when we don't. Calcium nitrate. Our rules still apply. Calcium is a +2. Nitrate is from our polyatomic ion sheet, NO3 -1. And we're still going to crisscross those. So we're still going to take our 2 and our 1, we're still going to crisscross them. So right now we would have Ca, we have NO3, and we're going to put a 2 behind it. Now if we just leave it like that, we're saying that we have NO32, and that is definitely not accurate because NO3 is nitrate, not NO32. So we need to put that NO3 in parentheses so that it can stay as one item, and we're saying that it takes 2 of those to equal the calcium. So calcium is a +2, nitrate is a -1. It takes 2 of those, so it takes 2 -1 charges to balance out the +2 of calcium. And that's why those parentheses are needed. Let's try another one with calcium carbonate. So calcium is still the +2, but carbonate is the CO3 -2. Notice that you have +2 -2. So these already cancel each other out. If you were to write Ca2 and then CO3 in parentheses with a 2, it would be like an earlier problem where we need to reduce it to lowest whole number ratio. So CaCO3 should be your final answer. Lithium chromate. Lithium is in the +1 column. Chromate, CrO4 with a -2. You get that from your polyatomic ion sheet if you don't have it memorized already. And again, we still need to crisscross, and in this case the lithium is putting a 1 behind the CrO4, and 1s are just understood. We don't need to have parentheses with a 1 because we don't write 1s. 1s are just understood. But that 2 from the chromate does get put behind the lithium. So Li2 and then CrO4. Last example, ammonium phosphate. Ammonium is a polyatomic ion. Phosphate is also. So both of these are from your little half sheet. NH4 plus 1 for ammonium, PO4 minus 3 for phosphate. And you still need to crisscross your charges. The 3 behind the phosphate, because you are putting a number behind a group of polyatomic ions, we need to keep it separate. So we need to say that NH4 takes 3 of those to balance out the PO4. And again, we would say that it takes 3 of the plus 1s plus 1 of our negative 3. So 3 NH4s, NH4 is a plus 1, 1 PO4, PO4 is a negative 3, and that should balance out to 0. So we get plus 3, here we have minus 3, and that does work out. Your charges always need to balance to 0.